I'm going to tell you how to find the inverse of points if you've been given some points, or of some graphs, and then we're going to talk about how to determine if a graph has an inverse function, and then one-to-one. Right? So if you're given a set of points like 3, 7, 12, 8, -4, 9, okay, the way that you find the inverse of the points is just to switch the x and the y values around. So you have 7, 3 for this first point, then you have 8, 12, and then you have 9, -4. And that's as much as it is for finding the inverse of a set of points. So if I were to give you a different set of points, say I were to give you 13, 6, -4, 26, and 7, 13. I'm going to switch the x and the y, so I get 6, 13, 26, -4, and 13, 7. Okay. Now, if you're given to a table instead of a set of points, you just switch the x and the y values. So if you have your table and you have 0, 1, 2, 3, and you get 5, 7, 9, 11, if you want to find the inverse table, all you're going to do is switch around your x and your y values. So I would have 5, 7, 9, 11, and I would have 0, 1, 2, 3. So that's what I can do to find the inverses given a table. Now, if we have a graph, I'll try to be mostly precise here. If you have a graph, you also switch x and y to find your inverse graph. Okay, so for example, if I have, let's do a parabola. Okay, so this is our graph. Okay, I'm going to remake my points so that you can see those. So if I want to find the inverse function, what I'm going to do is I'm going to take these set of points and I'm going to switch them around. So 1, 1, well, when I switch 1, 1 around, it stays as 1, 1. When I switch 2, 2 around, it stays to 2, 2. When I switch 3, 1, 2, 3, 4, 5, we get 3, 5, so I would go 5, 1, 2, 3. If I have 0, 2, I would have 2, 0. And if I have -1, 1, 2, 3, 4, 5, I would have 5, -1. So I'd end up with this picture that looks like that. Now, our inverse graphs have a special relationship in that they are symmetrical about this line called y equals x. Okay, so if we have this line right here, it's going to, if I were to fold on the blue dotted line, the red graph would turn into the green graph, and the green graph would turn into the red graph. Okay, so another way to do that is when you create your graph, you can fold across this line. So it always has a y-intercept of 0 and then a slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1. And then you can fold it across this line. If you color in the red graph with like a pencil and then you fold it across and then you scratch on it, it will give you this graph. So that's a second way that you could look at it. So if I wanted to find the inverse of, let's see here, do a dark green. If I wanted to find the inverse of this graph right here, this is an absolute value graph. So if I wanted to find the inverse of that graph, I would switch around the x and the y values. So I'd switch this point of 1, 2, 3, 4, 4, 2, or sorry, negative 4, 2 to 2, negative 4. So that would go over here. And then I would switch negative 3, negative 1 to negative 1, negative 3. This marker is not working well. And then I'm just going to go back to blue. So then this point would be 1, 2, 3, 4, 5. Oh, just 5. 5, negative 2, so I'd go to, or sorry, negative 5, negative 2, so I'd go to negative 2, negative 5. 3, 4, 5. Okay. So then I get that picture. Notice that if I were to fold on the blue dotted line, I would again get a graph, the green graph turn into the blue graph, and the blue graph turn into the green graph. Now, with your functions, in order to tell if a graph has an inverse function, we have a test that we can run on it. So we call it the vertical line test. So if I have a graph here, and let's say we have a square root graph, so your square root graphs look along the lines of that, so they start at a super point and shoot over. Okay, so and then continually go up. You should remember, in order to tell if something is a function, you could do a vertical line test. So if I draw any vertical line, and if any of these pink lines touch the green graph more than once, then it's not a function. Okay, this was the vertical line test that you previously learned about. So it passes the vertical line test because each pink line only crosses the green graph once. Okay? Now, if we do the horizontal line test, which is a very similar test, but just going horizontally instead of vertically, the horizontal line test will tell you if the inverse of the square root graph is a function. So if I draw, oh, I forgot that marker didn't work. If I draw a horizontal line anywhere here, notice that it only hits it once, and the green graph is continually increasing just a little bit. So this is really just one point that it's hitting. This is just one point. And this is continually going up little bit by little bit. So it also passes the horizontal line test as well as the vertical line test. So if it passes the horizontal line test, we call the inverse a function. If it passes both the horizontal and the vertical line test, then we call it one-to-one, meaning that each x has exactly one y value and each y value has exactly one x value. Okay? And that's what a one-to-one function is. Okay? So if we take a look at another graph, so let's say that we have this graph of a parabola. Okay, that was not a greatly drawn parabola, but it will work for our purposes that we have. So this parabola, if I were to draw a vertical line anywhere, it would pass the vertical line test, which means that the parabola is a function, which it is. Now, if I run the horizontal line test on it, if we look here, if I draw a horizontal line, this pink one line touches the green graph twice. So it fails the horizontal line test, which means that this parabola, its inverse is not a function. Okay? Because it fails the horizontal line test, it also means that this function is not one-to-one, because it has to pass both the horizontal and the vertical line test in order to be one-to-one. So if I were to give you, let's say, an exponential graph. Now, remember with exponential graphs that your graph right here, even though it looks like it's going along the same lines, that it's just getting a little teeny bit closer to the x-axis and a little bit teeny bit closer and closer and closer and closer and closer until it's so insanely close that it's just going to appear as if it's on the x-axis. Okay. An example of this would be if I were to go, let's just say, half the distance in between my fingers. Well, if I go half the distance in between my fingers, I've got right here, and then if I go half the distance again, I'm here, and then half the distance I'm here, and then half the distance I'm here, and then I'll keep getting closer and closer and closer to my finger, but I'll never actually make it all the way to my finger. I'll just get really insanely close to it. So when I do the horizontal line test on this, when I run this line through it, it appears as if it's hitting it multiple times, but we know, because this is an exponential, that this is really coming down just a little bit by a little bit by a little bit each time. So when I do a horizontal line, it's not actually going to touch it more than once. So this passes the horizontal line test. So this function's inverse is a function. Now, if we check the vertical line test as well to see if this is one-to-one, the vertical line test is passed as well. So because it passes both the horizontal and the vertical line test, then your exponential function is one-to-one. And that's how you figure out if the inverse of points or a graph, or if a function from a graph has an inverse function, and what one-to-one is.